Okay, so I want to go back to the idea a little bit about the identity. So we showed it, but if you take a matrix and you multiply it times the identity, then you're going to get that matrix back, okay? Just like you were multiplying by 1 times, a real number. And it also works the other way. If you take the identity times a matrix, it's going to be that matrix. Now remember, an identity has to be square. Has to be a square matrix. And also, when we talk about having an inverse, you can only have an inverse of a square matrix, okay? Only square matrices have inverses. And the other thing is, not all square matrices have inverses. So, not all square matrices have inverses. Some of them just don't have inverses, okay? All right. When a matrix has an inverse, it's called an invertible matrix. Okay, so this means that it has an inverse. And we're talking about multiplicative inverses here. Okay. So when we have so if you have a matrix A, then the inverse is A inverse. Now, when we have a matrix times its inverse, that's going to equal the identity for that, whatever the dimensions are, okay? And it also has to work the other way. So you take the inverse times the matrix, and that also has to equal the identity, okay? Now, we've been doing some of this, like when I was showing you the identity above and when we were talking about multiplying these, a lot of times a matrix multiplication is not commutative, but sometimes it is, okay? Like in this case, if you're multiplying a matrix times its inverse, that is commutative. And similarly up here, when we were multiplying the identity times a matrix, that was also commutative. But that's the exception, not the rule. Okay, so we'll show you more how to work with this in the next video.